Good morning, one and all. So today we'll discuss about Unit 3, direct and bending stresses. Direct and bending stresses. So first we'll see what is direct stress and what is bending stress. So direct stress is produced in the body when it is subjected to axial tensile or compressive load. Axial tensile or compressive load, that is called direct stress. That means the load which is passing through the axis, whether it is either it may be axial tensile or axial compression. So that particular stress is called direct stress. So direct stress can be calculated from this formula: sigma naught is equal to P by A. Applied direct load by cross-sectional area, you will going to get direct stress. So now we'll see what is bending stress. So bending stress is produced in the body when it is subjected to bending moment. When it is subjected to bending moment. So bending stress is produced when the body is subjected to bending moment. The bending stress will going to produce. So bending stress can be calculated from the bending equation. So from this bending equation, m by I sigma yy. From this bending equation, sigma b will be your bending stress. Right? Sometimes combination of if a body subjected to axial load as well also bending moment, then the both stresses will produce in the body. So that is called a direct and a bending stress, combination of direct and bending stress. Okay. So direct load will produce direct stress and bending moment will produce bending stress. If a body is subjected to both loads, then direct stress, combination of direct stress and bending stress will going to develop, will produce in the body, that is called direct and bending, combination of direct and bending stress. So now we'll see the effect of combined bending and direct stress. I will going to calculate maximum resultant stress from this direct and bending and direct stress and bending stress nunchi manam how to calculate the resultant we'll see here. So we know direct stress can be calculated from this formula load by area, and the bending stress can be calculated from this formula. Bending stress can be calculated from this formula m by I, bending equation m by I is equal to sigma by y. So now, so to produce maximum effect, to get maximum effect, so we have to combine these two stresses. That means we need to add these two stresses, direct stress and bending stress. So now we know direct stress is P by A, direct stress is P by A. So to get maximum stress, we have to add direct stress and plus bending stress. So direct stress is sigma naught, bending stress is sigma B. So direct stress is sigma naught is nothing but P by A. Bending stress is from the m by I sigma by y. So we can write like this. So depending upon this different sections, whether it is a rectangle section or a circular section, moment of inertia will be different, right? So we'll see here. So bending stress m by I is equal to sigma by y. Sigma b is equal to m by I into y. Sigma b is equal to m by I into y. So here is I is the moment of inertia. Moment of inertia about bending axis. So ఎట్లా bend అవుతుంది ఆ particular axis ని మనం తీసుకుంటాం. Let us suppose if you see this, if you consider this section, if this is a, if you are considering this is a column, because of the eccentricity, moment will going to develop. Moment is equal to P into E. So moment will going to develop on the vertical axis. About vertical axis, it will bend about this vertical axis. So we have to consider moment of inertia about vertical axis only. Iyy we need to consider. So Iyy for the section is dbq by 12. So we have to substitute I is equal to dbq by 12 and y. So you are going to get for this rectangle section. For the rectangle section, moment of inertia is dbq by 12. For it is a circular section, pi d power 4 by 64. Pi d power 4 by 64 we have to use. So, but the basic formula you need to remember, this will be the basic formula. To get maximum effect, direct stress plus bending stress you have to use. To want minimum stress, direct stress minus bending stress. So these are the two formulas. Minimum stress will be direct stress minus bending stress. So how to calculate direct stress? Simply P by A, load by area. If it is a rectangle section, area is equal to B into D. If it is a circular section, pi by 4 D square, pi by 4 D square, right? So bending stress, how to calculate bending stress? M by I from the bending equation. M by I sigma by y is equal to E by R. So from this you can calculate bending stress sigma B. Sigma B, bending stress sigma B, you can calculate sigma B is equal to M by I into Y. So we can write like this. I by Y could రాసుకోవచ్చు కదా, దీన్ని M by Z అని కూడా అనొచ్చు. M by Z. So Z is the section modulus. Sigma B is the bending stress. Bending stress is equal to M by Z. Right? So this is the basic formula you need to remember. So direct stress plus bending stress అంటే maximum stress వస్తుంది. Direct stress minus bending stress అంటే minimum stress వస్తుంది. For any section, whether rectangle section or circular section, whatever the section it may be, you have to follow this procedure to calculate maximum effect, maximum stress and minimum stress. Okay. For rectangle section కాబట్టి మన moment of inertia dBq by 12 కాబట్టి దాన్ని సబ్స్టిట్యూట్ చేసుకుంటే మనకు ఫైనల్ గా వచ్చిన ఆన్సర్ ఇది. So P by A of maximum stress is equal to P by A of 1 plus 6 E by B. Minimum stress is equal to P by A of 1 minus 6 E by B. So these are the formulas only for the rectangle section. These formulas will be different for circular section, right? So that's why if you is given any type of section, so you have to remember the basic formula, basic concept you have to remember, that is maximum stress will be equal to direct stress plus bending stress. How to calculate direct stress? P by A. How to calculate bending stress? From the bending equation. From the bending equation you can able to calculate. So to get maximum effect you need to add both. To get minimum stress we have to detect direct stress, bending stress from the direct stress. Okay. So this is the basic concept of direct and bending stress. Now we'll see one problem. A rectangular column width is 200 mm and thickness is 150 mm, carries a point load of 240 kN at eccentricity of 10 mm as shown in figure. Determine the maximum and minimum stresses in the section. Simply maximum stress ante sigma max is equal to P by A plus M by I into Y. This is the formula. M by Z inte inga. So P by A of moment ఎంత వస్తుంది, moment is equal to ఏంటి ఇక్కడ, because of eccentricity moment is coming, so m is equal to P into E. Okay, what is I? Moment of inertia about y axis. So bending along y axis అవుతుంది కాబట్టి we have to take dBq by 12 y. So y value maximum మనము maximum distance we have to consider y value. Okay, so if you substitute y value also, okay, you are going to get the maximum stress. Otherwise you can use the formula. From the derivation you can use the formula. Sigma max equal to P by A of 1 plus 6 C by B. Sigma minimum is P by A of 1 minus 6 C by B. So from this you can calculate the maximum stress and the minimum stress. After calculation of maximum stress and minimum stress, you have to draw the stress distribution diagram. This will be the stress distribution diagram. So maximum stress we are calculating 10.4. You need to represent here. Minimum stress here you need to represent here, and you need to draw this diagram. So this is the basic how to calculate maximum stress and minimum stress. So now we'll see another problem. Minimum stress in the section is 0 in the minimum stress 0 ante what is mean by minimum stress? That is P by A of 1 minus 6 C by B, or sigma naught minus sigma B is equal to 0. Sigma naught minus sigma B is equal to 0. If we equate this, P by A of 1 minus 6 C by B is equal to 0 చేయండి. దాంట్లో నుంచి మీకు ఎంత ఎసెంట్రిసిటీ కావాలని అడుగుతున్నాడు, ఎసెంట్రిసిటీ ఎంత వస్తుందని అడుగుతున్నాడు, maximum stress ఎంత వస్తుందని అడుగుతున్నాడు. You can able to calculate. The concept is only simple concept. Maximum stress అంటే P by A of 1 plus 6 P by A, that is maximum stress will be equal to direct stress plus bending stress. Minimum stress will be equal to direct stress minus bending stress. So this you need to remember. This is the basic concept, right?